All right, folks, we're continuing with synthetic division, and I wanted to do another example for you, and then I'm going to let you do a couple of examples, and then I'm going to show you some other interesting things that can happen when you're doing synthetic division. All right, so here's what we have. We have this polynomial, x to the fourth minus 2x cubed minus 10x squared plus 17x minus 1 divided by x plus 3. Because this is 1x to the first power, it qualifies for synthetic division. So I'm going to go ahead and do my setup. So I'm going to draw a half box. And what am I going to put inside the half box? Remember, it's going to be the opposite of whatever is here. So instead of 3, I'm putting negative 3 in, right? So I'll put negative 3 in the half box. Then I'm going to draw this line here. And then I'm going to put the coefficients here. What's the coefficient of just x to the fourth? There's a 1 in front of there, right? So we're going to put a 1 here. Then what's the coefficient here? I got negative 2, then negative 10, then 17, then negative 1. All right, there's all my coefficients and my constant at the end. So I'm set up. Now I'm going to execute. First thing I'm going to do is I'm going to put a 0 under the first number, and I'm going to add. 1 plus 0 is 1. Then I'm going to multiply. 1 times negative 3 is negative 3, and I'm going to put that here. Negative 3. Then I'm going to add negative 2. By the way, you can use a calculator for this. Okay, so a calculator can make this really easy because the numbers keep getting carried forward. If you key in 1 plus 0, you'll get, and then enter, you'll get 1. Then hit times negative 3, you'll get negative 3. Then just hit plus negative 2 or minus 2, and you'll get negative 5. Negative 5 times negative 3 is 15. 15 plus negative 10 is 5. 5 times negative 3 is negative 15, plus 17 is 2. 2 times negative 3 is negative 6, plus negative 1 is negative 7. And now, since my original polynomial started off as an x to the fourth, so this is the x to the fourth, this is the x to the third, x to the second, x to the first, and the constant. This down here is going to become 1 power less than the column it's in. X to the fourth, this becomes x to the third. So now this is 1x to the third, or just x to the third, minus 5x to the second, because I'm going down in power. X to the third, x to the second, x to the first, constant, remainder, right? So minus 5x squared plus 5x plus 2, and then I've got a minus 7. So I'm going to put minus 7 over x plus 3. And there we go. That is my quotient. This is the same thing as this rational expression using synthetic division. Okay? Go ahead and pause the video, try this out, and then I'll show you how to do it. Okay, so hopefully you had a chance to try this out. I hope you started off by doing a half box and putting a positive 5 in it, because this says minus 5, so this should be positive 5, because 5 minus 5 is equal to 0. My numbers across the top, just the numbers, ignoring the x's. I got a 3, a negative 10, a 3, a negative 10. I got a negative 31. I've got a positive 40, and then I've got a positive 7. I'm going to draw this line here. You don't have to draw the line first. You can draw the line after doing the numbers. Then, now we're going to execute the synthetic division. I'm going to put a 0 under this 3, and I'm going to add. 3 plus 0 is 3. Notice that this number down here is always the same as this number up here. That's why a lot of teachers, the way they teach the first step is, they just say carry down the first number, which is fine. If that's how you want to do it, that's great. Okay? So now, 3 plus 0 is 3. 3 times 5 is 15. I'm going to put that over here. 15, it's 15 minus 10, or 15 plus negative 10. That's the same thing. Gives you 5. Then 5 times 5 is 25. Minus 31 is negative 6. Negative 6 times 5 is negative 30. Plus 40 is 10. 10 plus 5, or excuse me, 10 times 5 is 50. And 50 plus 7 is 57. So our remainder is 57. Because we started off as an x to the fourth, we know that our answer is going to start off as x to the third, 1 power less. Okay? So this is going to be 3x to the third. This is a positive 5, so that's plus 5x to the second, minus 6x, x to the first, or just x, plus 10, And then our remainder is positive 57, so plus 57 over x minus 5. And there's our synthetic division. We're done. I hope you did pretty well on that one. I'd like you to try another one. I'm going to put another one up here, then you pause the video, you work it out. I think you're going to be in pretty good shape. This should be a good one for you. Go ahead and pause the video, see how you do. All right, hopefully you had a chance to work this out pretty well. If you didn't do so well, here's what I recommend you do. As I'm working through the solution here, you can pause. Like if I do a step, if you did it wrong, if you did it differently, then pause it and then try to get one step ahead of me. And then watch again and then pause it and try to get one step ahead of me again. That's one of the ways that we learn as human beings, is we try to predict what's about to be the next step, or what a teacher or professor is about to write up on the board. If you can stay just a little bit ahead of your professor or teacher and you know what they're about to write up on the board, then when they write something differently than what you thought they were going to write, you can raise your hand and stop them and say, hey, I thought you were going to write something different up there. Why did you write that? And then they can explain, and then you get knowledge and you understand. Okay. All right, so let's do this. Hopefully you did okay on this. I would draw a half box, and in that half box I would put a -2. Okay? And then I'm going to put all my coefficients right across the top here. So I've got a 6, a 14, a 5, and a 2. A 6, a 14, a 5, and a 2. Then I'm going to draw a horizontal line, right? Then I'm going to put a 0 under the 6. 6 plus 0 is 6. Times -2 is -12. Plus 14 is 2. Times -2 is -4. Plus 5 is 1. 1 times -2 is -2. And -2 plus 2 is 0. Oh, look at that. A remainder of 0. Now, you may have seen that and thought to yourself, well, now what do I do with a 0? Well, it's actually, when you get a remainder of 0, that's even better than getting a remainder that's another number. Okay? And I'll show you why in a minute. Now, let's write our answer. It started out as x to the 3rd power, so our answer is going to start off as x to the 2nd power, right? So this is going to be 6x squared. We got a positive 2, so that's plus 2x, and a positive 1, so plus 1. And what are we going to write for the remainder? We are going to write nothing. When there is a 0 in for a number, we skip it. We don't even write that part of the polynomial. So this is actually the final answer. And what this means, because we have a remainder of 0, and I'm going to explain this to you later, not right now, but I'm going to give you a little foreshadow here. When your remainder is 0, that means that the denominator is a factor of your polynomial. It's officially a factor, as if you were factoring. And so we could say that, we would now say, we know that x plus 2 is a factor of this expression in the numerator. Okay? All right, well, that's enough for this video. I've got one more video for you to watch, and in that video, I'm going to focus on what happens when we have zeros in our answer. And also, there are times when you have to know when to put a 0 in the top numbers, and that's going to be the focus of the next video.